Hey guys, welcome back. Let's jump in. We are finally getting to what I would call algebra, and I'm excited. What we've done so far, I'd say, is more like arithmetic, just learning how to work with numbers and operations. Now we're getting into the concepts of algebra, which I enjoy. I think it's a bit more fun, so I'm glad we're diving in. This starts our new week, and it's going to be the solving equations series. That's what we're going to be working on the next week. And we're going to start today with one-step equations. First, let's clarify. We've got expressions versus equations. Expressions we were working on this past week. We've already worked with them. And the two things we can do is evaluate them. I could give you a value for this x. You could plug in and you could get an answer. Or you could just simplify and put together any like terms. But notice this expression doesn't have anything on the other side. So, for instance, right now, there's nothing we can do. This guy is simplified, and if I don't give you any value for x, it just sits. There's nothing to do with an expression unless you're given a value for x or there's some simplifying to do, and it's open-ended. So that's what you can do with an expression. But now we're jumping in with equations. And equations look a little bit different. They are different because the equation, notice, has both sides filled in. There's something on both sides which locks this guy in. That means now we can solve for x, and in fact, there is only one value for x. If we work through and solve that equation, there's only one number that exists that we can plug in, that if we multiply that value times negative 12, then we add a negative 8 to that number, that it's going to actually equal the 32. There's only one value, and so equations are now solvable. We can solve an equation for the variable, because right now we don't know what that value for x is. Maybe it's 5, maybe it's negative 3. We don't know until we learn how to solve it. We'll do a process that kind of works downward like we would simplify an expression, and at the end we should have something like this. And in this case, if we did it, I believe, doing it in my head, we should see this in just a minute. That x equals 2, and that's the value that makes that equation true. Okay? So that's what we're doing now. That's how they're different from expressions. Both sides are locked in, and your job is to figure out what that x value is by simplifying and working that equation to just the variable x equals, and we'll see its solution. All right, let's jump in. Okay, the scale, really, really important concept for you guys to understand this idea of an equation. And right here, if we notice, they've got this equal sign here. So this is kind of like a balanced, this is a scale that's pretending like it's an equation, basically. We've got values on this side, we've got values on this side, and it is a balanced equation, and it's at the same time like a balanced scale. So if we were to play around a little bit, and notice we've got the two things on the scale. We've got blocks, and then we've got bags. Blocks are kind of like just numbers. A block equals a 1. So there's 1 on that scale. There's 7 units on that scale with the little blocks. Bags, we don't know what's inside a bag. There's some unknown number of blocks inside of a bag, so that's like a variable. It's like x. We don't know what is inside x. All right. And of course this has to happen when I'm trying to work. All right, let's try this. It's balanced right now. If I add something to one side, I just unbalance the scale. I could rebalance it by simply adding a block. I put a block on the left, so I'm going to add a block to the right. And now I rebalanced it. I could take one of the bags off the right-hand side, and I just unbalanced it. So I'll take a bag off the left and rebalance it. Now I'm hoping this seems pretty straightforward to you guys. We just need to understand one basic principle. If this scale starts equal, then we need to keep it equal. And the way we do that is if I'm going to add a bag to this side, I need to add a bag to this side. If I'm going to take a cube off on the left, I need to take a cube off on the right, and it will stay balanced. Okay? When we get the scale, the equation will always be balanced. Your job is just to continue keeping it balanced as you unload the scale and get it down to just the variable. So in terms of this problem, I would say I'm going to take off a block from, let's see if we can, well, looks like it doesn't work. We're moving on. Okay, so rule number one to balance equations right here. You must do whatever you need to, whatever you do, to both sides of the equation. Okay? That's the bottom line, super important. Do it to both sides of the equation. Okay? So as we work, you'll always be doing left side, right side, left side, right side. Whatever you do is to both sides of the equation. Okay? Let's look at this real quick and see how this works. I've got over here 12 equals 3 times 4. Now, 12 is 12. We know that 3 times 4 is 12. So right now we can see this is a balanced equation. The equal sign is true. It's 12 on both sides. So could I do this? Could I add 3 to this side and add 3 to this side? Would it still stay balanced? Let's see. 12 plus 3, 15. And I'm going to leave that 3 times 4, and I'm just going to add the 3 to the other side. So we've got 15 on one side, and if we check 12 and 4, 3 times 4 is 12, add the 3, yep, it does check out. That is still a balanced equation. So as long as I do whatever I'm going to do to both sides, it'll maintain a balanced equation. And you're allowed to do that. Once we start working with equations, that's going to be our job. Add something to both sides, subtract something, multiply something to both sides. We're going to manipulate that equation, change it around, but just make sure you always do it on both sides. One more quick example. 10 plus negative 2 does equal 8. There's a little practice on our integers. 10 good guys and 2 bad guys. If I were to multiply both sides of this equation by 2, and notice I'm multiplying the entire thing by 2, let's see what happens. 8 times 2 is 16, and I'm going to leave that 10 plus negative 2 in place. And I'm just going to write the 2 right next to the parentheses, which means it's distributing, so it's just multiplying with whatever's inside. 10 plus negative 2, that's 8. If I multiply the 2 times the 8, I, of course, get 16. It matches. That means I've got a balanced equation, and it's true because I did whatever I did to both sides. Okay, so that's rule number one. Always work on both sides. You'll never go wrong. Okay, now let's talk about when we actually start solving. Let's talk about isolating a variable. What the heck am I talking about? Let me show you. If you see this equation right here, where do you start? Some of you guys, I'm sure, some of you look at this equation or bigger, more advanced type of equations, and you're just not sure where to start, and you get stuck right from the beginning. Well, I'm going to help you. Where do we start? We start by noticing here's x. That's what I want to get by itself. I want to isolate the variable. So the x is not what I attack or what I work with, but I look at what's on the same side of the equation with x. My goal through some work is to see x equals and some value on the other side in a little bit. I want to unlock or open up what's inside of x and be able to see it. So what I'm going to do in this equation is the same one as right here. What I'm actually going to target is everything on the same side of the equation as x, and those are the values I'm going to get rid of. Okay, so that in a minute, all that's left on the left side of the equation is x, and I can see what it equals. Okay, so that's your job. When you get an equation, look at that equation and get rid of the values around your variable, and I'll show you how to do that. But that's what we're looking at. That's how we start. So the second one, there's another one to look at. I've got p. P is what we want to isolate, but we don't start with p. We don't actually deal with p. We just start on that side of the equation, and I call it actually number assassins. You guys are number assassins. You can put a little target on here. That's what you're trying to take out. You're trying to take out these numbers. Okay. We are going to assassinate or get rid of everything around p so that in a minute we have just p equals and we can see what p's value is. Okay, so that's what we're doing. We're going to target everything around the variable and get rid of those. Let's show you how to do that. Okay, how do we do that? And I'm going to just say right now, we've got x minus 4, and what we just saw on the other page is that that's what we want to get rid of. We want to get rid of that minus 4. We want to see what x is by itself. So let's think about what we're saying. We're solving an equation. I want to know what x equals. And on something really simple like this, I'm sure you can tell me. What number, when I take away 4, equals 12? Shout it out. Go ahead. I bet somebody just talked through the computer. You're weird. Just joking. Okay. It's going to be 16. Probably we can see that. What number, when you take away 4, you'll end up at 12? It's going to be 16. Okay. I want to get back to that original 16. So if we're thinking about it in our head, we had 16. We subtracted 4, which brought us down to that 12 that it equals. I want to come back up to just x and cancel the 4. Since I subtracted off those 4 units, I want to go back up to those 4. Back up those 4. I want to get back to the original value. So if I had 16 and took away 4, I want to build back up to the 16. I want to add 4. Okay. And so really, it might even be simpler to look just at the right side. If I take away 4 and add them back, then I can see, oh, it was 16 that I began with. Let's look at this one on the right-hand side. M plus 7. M plus 7, okay, that's what we want to target to get rid of. That's what we want to deal with, equals 13. What number, I'm going to add 7 to it, and I'm going to end up with 13. What number would that be? Hopefully we're saying 6. Okay, so we know it's 6. We can see that on these easy problems. So we're thinking, okay, I was at 6, I added 7. So if I added 7, I want to be able to reveal and see where I started. I need to take that 7 back away. 13 minus 7 is 6. That's how I can see that. So this is showing us the second important rule. If I'm taking away 4, in order to get back to the original value and see what x is, I'm going to need to add that 4 back. That's going to bring me back up to what my answer is. If I'm adding 7, I'm going to need to take that 7 away in order to get back to where I started. Okay? And that's the idea here, bringing us to our second rule. And don't worry, there's only 2. These 2 rules are pretty much all you need to start solving equations. We need to use opposite operations to cancel off a value. Okay? When I say opposite operation, I'll even make that clear. If you are adding, boy, how many times do I do that, guys? You keep seeing me do that. If I'm adding, the opposite operation is to subtract. Okay? If I have a subtraction, the opposite operation is to add. If I am multiplying, remember parentheses mean multiply. The opposite operation of multiplication, what undoes it, what cancels it, is division. And just like that in reverse, division, if I want to undo that, its opposite operation is to multiply. Okay? So when I say opposite operation, that's what I mean. If you were adding a value, you need to subtract that back off. If you were to be multiplying a value, you would need to divide that back off of the answer to see what that x was before it was changed. All right. We've got our 2 rules right here on the right. Let's apply those and start solving some equations. Rule 1, balance. Make sure we're doing whatever we do to both sides. And then number 2, we'll cancel values by using the opposite operation. We're going to do it first on a couple of add-subtract problems. So we'll look at number 1. X minus 6 equals negative 12. Now, chances are once we throw negatives in there, it gets harder to see the answer in your head. And that's true for me, and I'm the math teacher. When I look at this, the way I figure out the answer is actually by solving it in my head right now using the two rules. Just looking at it and intuitively knowing the answer, I get lost in the negatives. It's hard for me to see it, so I use the rules. Probably that means you should too. Okay, so let's look. We know that we are subtracting off 6 from x. So in order to get back to the original x, we should add that 6 back on. Okay, we're just going to add 6 to that negative 12, do the opposite, then we can see what we were at to begin with. But to make sure the equation stays balanced, rule number 1, we've got to do the same thing to both sides. Okay, and so we see here a negative 6 and a positive 6. Those cancel out, which is what we want. 6 bad guys, 6 good guys cancel out. They just drop out of the equation, and I'm just left with x on that left-hand side. Now we'll add the 6 to that negative 12, and this is your good guys, bad guys. It's why we worked on this for that first week. Remember, this is 12 bad guys, 6 good guys. So even though it says add, we're combining them. They're fighting. It's a subtraction. More bad guys, so the bad guys win the fight. And there you go. We see that x equals negative 6. Okay? We followed our two rules. We made sure to do the same thing on both sides, and we used the opposite operation to cancel our value. Let's do it again on number 2. Again, if I look at number 2 to start, I see y is on the right-hand side. Things got switched around. That's okay. That means we're going to work on the right-hand side of the equation. The 8 is what's with y, so the 8 is what we're targeting because we want the y by itself. So we're going to look at it and we're going to say, okay, I've got an 8 that's adding to the y. How am I going to get rid of that? Well, I've got to take away the 8, and I've got to do the same thing on both sides to keep it balanced. 8 minus 8 is 0, leaving just y by itself. So we cancel that value by using the opposite operation, and then rule number 1, do the same on both sides to keep it balanced. That's going to let us see in just a minute what y equals. And we see negative 4 minus 8. This is something I often see kids trip up on when they're first learning their equations. Is that an add problem or a subtract problem? Think about it. If I were to rewrite it horizontally, will that help? Hopefully, we're saying addition. If you say subtract, that's fine, but you got to see that you need to rewrite it as addition to understand it well. It's just some bad guys adding together with more bad guys. That's what we want to see. That's why I've been pushing that with you guys. Once we get to equations, it's important to see that. So you can just throw a plus right here, and now it's negative 4 plus negative 8 equals negative 12, and we see what y equals. Okay, and we followed our two rules. We always use the opposite operation to cancel it, and then make sure to do it on both sides so the equation stays balanced, and then we can see what the variable equals. Let's apply that to you know what? No, let's get you some practice right now because I've been talking way too much. Let's have you just practice that type real quick before we go to multiply divide. And notice it doesn't matter which side the equal's on, or which side the variable's on. I'm going to put the variable on the right this time, and you can work for that side. Go ahead and, no, I don't care. Pause now, pause in a second, but pause me and do these two practice problems. And then I'll show you how to do them after you've finished. All right, work those two out. Let's see if you're getting the idea. And if you need to, no, you can't. Never mind. Remember rule 1, use the opposite operation to cancel. Rule 2, do the same thing on both sides. And you're looking on the side with the variable. So that's what you're trying to cancel off, whatever's around the variable. That's what you're trying to cancel off, whatever's around the variable. All right, let's dive in. To cancel off, oh, I swear that stinking highlighter. To cancel off that -8, we're going to add 8. So if we add 8 to both sides of the equation, it's going to keep the equation balanced, and it's going to reveal what the y value was before we took 8 away. We're balancing back out to just y. And again, look at your good guys, bad guys. Watch this as you're learning. That's -11 plus 8, bad guys and good guys. There were more bad guys. It's a subtraction, so it's -3. Okay, same thing on the other one. +9, we need to do -9. We're going to take away 9 so we can see what m was before we added that value. We're going to do the same thing to both sides. And again, see this as an addition of two groups of bad guys, negatives and negatives. Larger group of bad guys. All right, hopefully that made sense. Notice here, in this type of problem, the subtraction becomes addition. That's because it's the opposite operation. Okay? We are canceling an added or subtracted variable. If it's a subtraction that we're canceling, we're going to use addition. Not use the negative is if you're switching a subtraction and you have to cancel it with addition. In this type of problem, an add subtract, then you would flip the sign, okay? But not in a multiply divide. All right, let's now look at this with some multiplication and division. Same exact idea. Here I've got -4 multiplying with p. They're stuck together, guys. Anytime you see that, it's exactly the same as this. We don't use parentheses with variables because there's no way to mistake this for a number. It's clearly a number and a letter, so we know they're separate, so we just always assume it's a multiplication like this, and we just don't put in the parentheses, okay? All right, so right back up here, notice -4 is what's with p. So that's what we identify to get rid of, and we notice that they're stuck together. Remember, like two dogs stuck together are multiplying. Two values stuck together are also multiplying, so that's what you're getting rid of. On the other problem, the same side as the m is the -9, so that's what we need to get rid of. And these are actually the practice problems. You guys can practice in a minute. I'll show you guys how to do these. So right here, if I'm multiplying, I'm going to show division with a fraction bar, okay? Sometimes I'm a little leery to do that because kids freak out when they see fraction bars. Don't think of this as a fraction. Just think of it as division. In fact, if you wanted to, we could do it like this, and it's the exact same thing. A multiplied -4 is going to be canceled by dividing with the -4, okay? And if that makes more sense to you, you can just do that. But I'm going to show it as a fraction just because that's how you're going to see it on a test, on a quiz, on any kind of other thing you do. You're going to see the fraction bar. So I'm just dividing. And if I divide off, notice I divided the negative with it. The operation that we're canceling is the multiply and divide. The negative sign is part of the 4. I'm dividing that off with it. So pairs of negatives cancel, it all goes away. And then I do the same on the other side. So now it's just a little bit of division. 24 divided by 4 is 6. There's a single negative, so it doesn't cancel, it goes to the answer, and there we go. Okay, we'll apply the same thing on number 2. And again, don't see that as a fraction. Just see it as division. It would be the exact same problem if I wrote it like this. There's no difference. Okay, so don't think fraction when you're working with your equations. Just think multiply, divide. And when you see that fraction bar, just think divide. So the way we're going to get rid of that is, since it is dividing, we're going to multiply to cancel it. If I divide something by 9 and then multiply it by 9, I'm going to come right back to the original value. don't forget we've got to have the negative with it. Lots of kids won't use that negative, okay? You need to multiply with a negative as well. That's how the pair of negatives will cancel, leaving m by itself. And then I'm going to do the same thing on the other side. I'm going to multiply. That's terribly written. You guys have a terrible math teacher. Look how he writes. Multiply by negative 9. 3 times negative 9. Single negatives go to the answer. There you go. Negative 27. Okay, that's it. All right, one thing I'm going to show you before some practice. Notice on this type, the new page, the operation here is division. That's what we're switching to when multiplication. And so we're switching to division. You keep the negative. You don't get rid of it. Here, when we're dividing, the operation that we cancel is with multiplication. So if a negative is used, we use a negative to cancel it off. All right? The only time you would... There's a couple practice for you. All right, take a minute, do those two. Your two rules, do the same on both sides. And the opposite operation cancel. Go. All right, jump in and see if you're getting the idea here. On the side with x is this value, negative 3. That's what I'm going to cancel. And then I see with the fraction bar that it's division, which tells me I'm going to multiply to cancel that off. So I'm going to multiply, and I'm going to get rid of the 3, and it's negative. Okay? So if I divide by negative 3 and then multiply by negative 3, those are just going to cancel each other out as operations and leave x by itself. And now I want to do the same on both sides to keep the equation balanced. 9 times negative 3, negative 27. And by the way, I should have already showed you guys this. You can always plug back in to check, and that's kind of a guarantee to make sure you get an A on the quiz this week. If you check every problem and it works out, you know you got it right. If you check and it doesn't work out, you know you made a mistake and you can go back. So I can just replace that x with a negative 27 and see when I divide by negative 3, does it in fact equal that 9? And we can double check real quick. The two negatives would cancel. 27 divided by 3 does in fact equal 9. So I know I got it right. I know the equation balanced. It works. All right, number 2. 6 and p are multiplying, so I'm going to divide. I'm going to cancel it off by dividing. And if I were to multiply and then divide by the exact same number, I'm going to have the original value I started with, so that's p. I'll do the same on both sides. 6 into 18 goes 3 times. There was a single negative. Goes to the answer. And if I wanted to double check that, 6 times negative 3, I'll just replace p with my answer. What does it equal? It equals negative 18, which is what it's supposed to equal. So everything checks out. All right, do some homework to practice this stuff. Bring questions to class. Thanks, guys.